Hello, my name's Elliot Reid and I'm a Principal Transport Planner at City Science. If you haven't heard of us, we're a team of sustainable transport planners, modelers and software developers working in collaboration to develop innovative solutions in how we can tackle the transport decarbonisation challenge we face. Today, I'm going to give an overview of City Science's award-winning Cadence visualization tool, and in particular, how it can be used to assist with active travel and sustainable transport related projects. I say award-winning given it has recently won the Transport Technology Award at the recent 2019 CIHT Awards, back when we could meet in person. Having only recently joined City Science in summer, I'm relatively new to Cadence myself, but it's clear to me why there are four key benefits why Cadence's capabilities can bring efficiency to how we can deliver active travel and sustainable transport projects. Number one, it provides a one-stop shop by including a wide range of highly relevant open source datasets relevant to health and sustainable transport, such as established walking and cycling routes, the propensity to cycle, cycle mesh density, active travel mode share, alongside wider indicators including air quality, road safety, and deprivation indices. This avoids having to spend time sourcing and analysing the data first. Cadence is also highly flexible, and the use of the what-if functionality allows quick and efficient sustainable transport scenario testing, including the assessment of things like new development sites or route closures. Thirdly, it is able to quickly and efficiently produce walking and cycling catchment isochrones with just a few clicks. And finally, and probably most importantly, it provides a shared collaborative platform to engage and educate clients, key stakeholders, and members of the public through the process. Let's see it in action then. A live demo version of Cadence can be viewed for free at dat-stats.cityscience.com at the link above, without the need for a license, so feel free to have a play around there after this demo if you want to explore its capabilities further. I've loaded the Exeter OSM version, which includes our walking and cycling network catchment tool, but you can look at various other models, including Exmouth and Cleishoniton in Devon, to review Cadence's wider strategic modelling visualization capabilities, if you like. When we open the network view of the model, the first striking thing is how visually accessible it looks. The OpenStreetMap is center stage, which is highly customable, so we can turn off things like the node points, and links, or we could opt to use an ordnance survey map instead of OSM. That's the ordnance survey map there. Given we utilise UK-wide open data where possible, we can also zoom to somewhere else in the country. So let's search and go to a totally random place. We search for Cirencester, go there. Cirencester and Gloucestershire. As I mentioned before, one of the real advantages of Cadence is that we have a comprehensive set of preloaded open data sets embedded within the platform, which can help practitioners and stakeholders contextualize the active travel and sustainable transport data quickly and efficiently. As you can see, this includes a wide range of data, and one that is growing every few weeks or so. Let's say, for the sake of argument, that we wanted to represent and produce a local cycling and walking infrastructure plan, or an LC-WIP for short, for Cirencester. We could turn on layers such as cycleways, and here they are shown in blue. To complement this, we could also show other cycling outputs, such as cycle route mesh density, which is shown here. We can also customize how this data is shown through clicking this spanner icon at the bottom and playing around with its settings. So we could change its opacity, for example. We could choose what it was actually showing, so we could switch it to cycle lane length, for example. Or we could view it by buildings as opposed to output area boundaries, shown there. We can also use Cadence to represent sustainable travel behaviour. So for example, we could extract the propensity to cycle required for LC WIPs using 2011 census data. So if we went back into our tool and clicked on propensity to cycle, and here they are. I'll put the LSOA boundary to make it clearer. We can also pull in the key on the right-hand side to represent exactly what we're showing. We could also use it more broadly to obtain commuting behaviour. So we could turn on, for example, travel to work data from the 2011 census. And this is representing the proportion of people that are commuting by foot and by bike. Taking a step back, there's also an array of wider contextual open data sets. So we could, for example, toggle on local authority boundaries, shown there. Or we could toggle on detailed land use data, which is shown in this menu here. We could then use this data to cross-tabulate with other demographic and socioeconomic data sets, so including things such as population density, for example, which would be shown in terms of the road network there, or other elements such as the deprivation index, which is shown underneath that again on the screen. More recently, we've also built in a road safety feature, which pulls through Stats 19 data to represent collision hotspots. And there it is, shown on the screen. Now that we've established the range of open data sets, let's go back to Exeter to explore our recent walking and cycling catchment tools using the routes page. So if we go back to our menu and click on routes, so this tool could be used to determine the actual walking and cycling scope of our LC WIP, or it could be used to assess the impact of a route closure, such as a bridge or a level crossing, or equally assess the walking and cycling accessibility of a proposed development site, either to inform site filtering for a local plan or to directly assess the accessibility of a development for a planning application. Let's assume that I wanted to firstly examine the cycling accessibility of a new development site in the Marsh Barton area of Exeter. Firstly, let's turn off road collisions and go into our network menu. From our network type, we would select cycling. It just takes a few seconds to load. It's loading in a different network. We then click on baseline. and we would go back to our route options. Firstly, I want to drag my pointer to the Marsh Barton area of the city. So you can see that it's currently located up here. So it's as simple as moving it to a link in Marsh Barton, just like that. And the map catchment tool should update automatically now that I've dragged it there. Again, just give it a few seconds to compute. There we go. It's now calculated that. So in my route options tool, I could either calculate the catchment by distance or by time. So in this case, I'm going to use the time cost function, and I'm going to type in a maximum cycle catchment time of 20 minutes from our development site in Marsh Barton. And you can see that the map has updated to represent exactly what the cycling catchment is within that 20-minute catchment. And that takes into account street lengths and geographical barriers, such as the River Exe, for example. We can also pull this graph at the right-hand side, which provides a detailed breakdown of the distance to each of the links in our model. We can also toggle on other views in this menu here, such as isobands, to make our output more visually appealing. That's the isoband option there. Turn that off for now. Let's look at another example. In this scenario, let's assume I wanted to assess the impact of a bridge closure over the River Exe. And I'll assess the impact on walking accessibility from a local community and the degree of severance that it would result in. Firstly, I would go back to my network option and select walk, which again will load in the walking network for Exeter. I'd click baseline, which is already toggled on, and then I'd go back to my route options. I then need to drag my pointer to the Exwick area of the city, which is where I'm going to assess the relative severance. So first of all, we need to set this back to what it was so that we can get our links loaded up on the screen. Then I'm going to drag my pointer to an area around Exwick. And it should automatically update again. Yeah, there it is. It's taking into account the whole of the Exeter network from our location in Exwick. So if you just give it a few minutes, there we go. I'm going to limit this down to 15 minutes so that it's not calculating the entire network for Exeter. And this is our baseline scenario. Which effectively shows that we can walk across the River Exe towards Exeter St David's Station on the east side of the river. Now let's go and introduce our road closure. So if we go back into our network view and click Scenario, and then click on our ban link, which is the We Know Entry sign at the top there. And we're going to ban the link on the bridge itself. So there's two footways on either side of the road. So if we click one there on the north side of the bridge, and it should appear on our map. There we go. And we'll click one on the south side just to be safe. So we've effectively banned 2 links in the walking network. And if we go back to our route options and check that we've got everything the same, we can see that effectively the closure of those links has resulted in the catchment walking area being confined to the west side of the river, which is obviously going to cause severance issues for the community on that side. Hopefully that has provided a quick overview of Cadence's capabilities and what it can offer in relation to health and sustainable transport planning. If you want to play around with it more, please visit the link above or get in touch with us at info@cityscience.com. Thank you.